Students, our next topic is Gauss theorem or Gauss line electrostatics. This is a very important topic. In our earlier topic, we studied that electric flux phi E over a small area element ds held in a uniform electric field of intensity E. This is equal to E dot ds or E ds cos theta. Theta is the smaller angle between electric field intensity E and area element, small area element ds. Now we will study Gauss theorem or Gauss line electrostatics. According to the Gauss theorem, the surface integral of electric field E produced by any sources over the closed surface S enclosing a volume V in vacuum, or this is called total electric flux. Total electric flux over a closed surface S in vacuum is 1 upon epsilon naught times the total charge Q enclosed inside S. Therefore, phi E, that is the total electric flux over a closed surface S, or phi E is also called E dot ds, integral over the closed surface, that is total electric flux over the closed surface S, is 1 upon epsilon naught times the total charge Q enclosed inside S. This is Gauss theorem. Now proof of the Gauss theorem. Let us suppose that an isolated positive point charge plus Q is held at the center O of a sphere of radius r. According to Coulomb's law, electric field intensity at a point P on the surface of the sphere is E is equal to Q upon 4 pi epsilon naught r square r unit vector. R unit vector or r cap, this is a unit vector directed from O to P. Let us consider a small area element ds around P. Consider an small area element, ds of sphere around P. Let this area element is represented by ds vector is equal to ds into n cap, where n cap is a unit vector, along outward drawn normal to the area element ds. Now electric flux over ds, area element ds, this will be E dot ds. Now value of E is Q upon 4 pi epsilon naught r square, and this is r cap, E की वैल्यू ये यहाँ पर है, into r cap dot ds वेक्टर इज ds into n cap. अब इसको हम कैसे लिख सकते हैं? इसको हम ऐसे लिख सकते हैं, d phi e, this is represented by d phi e. d phi e is equal to E dot ds. This will be Q upon 4 pi epsilon naught r square ds, ये कांस्टेंट और बाहर आ गए, यहाँ पर r cap dot n cap into r cap dot n cap. As r cap is unit vector from O to P and n cap is a unit vector along outward drawn normal, as outward drawn normal at a point on the sphere is along the radius, therefore as r cap and n cap, they are in same direction, their magnitude is 1 and angle between them is 0, cos 0 is 1, therefore r cap dot n cap become 1. Therefore d phi e is equal to Q upon 4 pi epsilon naught r square ds, r cap dot n cap 1 हो गया. Now integrating over the closed surface, we get the total electric flux. Integrating over the closed surface, of sphere, we get total electric flux over the we get total electric flux over the closed surface of sphere. Therefore phi E integrating over the closed surface S. Now value of d phi E is q upon 4 pi epsilon naught r square ds integrating over the closed surface S. q upon 4 pi epsilon naught r square constant है, integration over the ds. Now ds is the small area element. When integrate over it, then we get the total surface area of this sphere. Total surface area of this sphere of radius r is 4 pi r square. 4 pi r square कट जाएगा. This is equal to q upon epsilon naught. Therefore phi E is equal to 1 upon epsilon naught times the total charge. This is phi E is the 1 upon epsilon naught times the total charge enclosed inside the closed surface. This is Gauss theorem. As if there are point charges, q1, q2, q3, qn inside the surface, then each charge will contribute to electric flux. Each charge will contribute to electric flux independent of other. Then total electric flux, this will be equal to electric flux due to charge 1, electric flux due to charge q2, electric flux due to charge q3, and so on, electric flux due to charge qn. Now electric flux due to charge q1 phi E1, this will be 1 upon epsilon naught times the charge q1. Similarly phi E2 will be 1 upon epsilon naught times q2, and so on, 1 upon epsilon naught times qn. This will be 1 upon epsilon naught q1 plus q2 plus qn, or this will be 1 upon epsilon naught summation I is equal to 1 to n qi, and this will be 1 upon epsilon naught q, where q is the equal to summation I is equal to 1 to n qi. This is the total charge. This is total charge enclosed inside the closed surface. Therefore total electric flux over a closed surface is 1 upon epsilon naught times the total charge enclosed inside S. This is Gauss theorem. It is to be noted that electric flux over a closed surface in vacuum is 1 upon epsilon naught times the total charge enclosed inside the surface, regardless how the charge may be distributed. चार्ज कहीं पर भी डिस्ट्रीब्यूट हो सकते हैं. If the medium surrounding the charge has dielectric constant K, then phi E total electric flux over the closed surface, this will be 1 upon K epsilon naught times Q. जब वैक्यूम था तो 1 upon epsilon naught times Q था, और if the medium surrounding the charge Q has dielectric constant K, then this will be 1 upon K epsilon naught times Q, or this may be written as K की जगह हम epsilon R भी लिख सकते हैं. Epsilon R is the relative electrical permittivity of the medium surrounding the charge. K is the dielectric constant of the medium surrounding the charge. This will become Q upon epsilon, because epsilon upon epsilon naught is equal to epsilon R or K. Therefore epsilon is equal to epsilon R into epsilon naught or K epsilon. Epsilon R into epsilon naught और K epsilon naught की जगह क्या आ जाएगा, epsilon आ जाएगा. If no charge is enclosed inside the closed surface, then phi E will be 1 upon epsilon naught times 0, this will be 0. Therefore electric flux through a closed surface is 0 if no charge is enclosed inside closed surface. Or algebraic sum of all the charges present inside the closed surface is 0. Electric flux through a closed surface is 0 if no charge is enclosed inside the closed surface, or algebraic sum of charges enclosed inside the closed surface is 0. It can be proved that charges situated outside the closed surface, they makes no contribution to the total electric flux over the surface.